Okay guys, this is review test 5.3. Starting off with question 1, of course. It says select the expression that could be used to describe the number of squares in the following pattern. If we notice, this is our first term, second term, third term, fourth term. It says that our first term has 1 square, second term has 3, third has 5, fourth has 7. So we know just from that it's adding by 2, okay? We know it's adding by 2. So based off of that, we can get rid of B and D because there's no addition sign in either one of those, okay? Now, we either have 1 plus n minus 1 times 2 or 1 plus 2n, okay? And the easiest way to tell is just substitute the number 1 in for n, okay? So if we had, let's look at C, it's shorter. 1 plus 2 times 1, remember our first term, it only has 1 square, so it has to equal 1. Well, 2 times 1 is 2, plus 1 is 3, it does not equal 1. Can't be C. The answer is A. This is just to show you, if we substitute 1 in for n, 1 minus 1, that's 0. 0 times 2, 0, plus 1, that's 1. It works. A is the answer for number 1. Number 2, write an expression that can be used to describe the following number pattern. So we're looking at the purple squares here. So it's half, 1/4, 1/8, so on and so on. We notice that it's decreasing by half, right? We know it's decreasing by half because half of 1/2 is 1/4. So we look at our answer choices and we can eliminate A right off the bat because there is no 1/2, right? And we can eliminate D because it's not going by 2, it's going by half. So now we have to determine if we have B or C. Well, we have an initial value of 1/2, and then it also is decreasing by 1/2. So we're going to need 2 halves, if that makes sense. But just to show you, we can substitute it in. For B, if we substitute it in a 1, we have 1/2 to the 1 minus 1 power. 1 minus 1 is 0. Anything to the 0 power is 1. It has to be 1/2. So it can't be B. Our answer is C. Because then with C, all they did was add the extra 1/2. So if we add the extra 1/2, 1 times 1/2, that's 1/2. The answer is C. Number 3, the following sequence is either arithmetic, geometric, or geometric, or neither. If it is arithmetic or geometric, determine the next 3 terms in the sequence by calculating. Okay, so we look at our numbers, it's going up from here to here. That's 25, then that's 50, 75. So it's not a constant rate, so it can't be arithmetic, and it's not multiplying by anything, so it's not geometric. In this case, it's neither. It's neither one of those. And D is the only one that's neither, so that's the answer. Number 4, we look at our numbers. Is it arithmetic or not? Let's see, 15 minus 4 is 11, 11 minus 4 is 7, 7 minus 4 is 3, and 3 minus 4 is -1. So yes, it is arithmetic, so we can get rid of B and D. And then we read A because the common ratio is -4. We know that arithmetic, it doesn't have a ratio, it has a difference, so it can't be A. It's C because it's a common difference. Geometric is the one with the ratio. So don't let that confuse you. We know that it has to be C. Flip the page. We are on number 5. Find the common ratio for the geometric sequence. So we look at number 5. 9, 27. So that's times 3. 27 times 3 is 81. So we know it's multiplying by 3. There's only one 3 there. The answer is C. Again, find the common ratio. So now 2 times negative 3 will give you 6. Negative 6. Negative 6 times negative 3 equals a positive 18. So we know it has to be 3. We just got to notice that when the signs are opposite, that we're multiplying by a negative number in order for that to happen. Because positive times a negative equals a negative. Negative times a negative equals a positive. Okay? So it has to be negative 3, not just 3. So, number 7, we look at our answer choices first. We notice that C and D both have the 2000 plus n minus 1. The only difference between C and D is that there's a 65 or a negative 65. And then A and B, A has 65 into the power of n minus 1, or with the power of n minus 1, I'm sorry. And B, it's 65 plus the 2000 times n minus 1. So first, basically A is geometric, B, C, and D are arithmetic, and we got to figure out if our initial value is 2000 or 65, and if it's initial or not, and then we'll see what happens. So then we read the question. At the beginning of each week, at the beginning of which week will Pedro make his final $65 withdrawal? So withdraw right there already tells us that it's going to be subtracting 65 every time. So we know it's not B because that's adding 2000. There's no subtraction in A. Can't be A. That's multiplying. That's geometric, not arithmetic. Now it's either between C or D. Just from reading the question, it's withdraw, okay? So we know that it has to go down, it has to decrease. So basically, is it 65 or is it negative 65? Well, if it's just 65, that would actually be increasing because we're adding positive numbers. But if it's negative 65, that positive becomes a negative, and now we're subtracting. And when you withdraw, you subtract. So the answer would be D. We didn't even have to read any of that. Just the actual question. Okay? But if you want, you can read it. It'll tell you that 65 is being taken away from the initial $2,000 deposit. So number 8, the first 5 terms of this, and then also that, right? So basically, we're asking for whatever terms we're asking for, you substitute that in for n. So if it was A1, you just substitute n in as a 1. So 2 times 1 minus 1, right? That's a 0, so that makes that a 1. 1/2 times 1 is still 1/2, so A equals A1, A sub 1 equals 1/2. Okay. And we know if we look at this equation, the one it gives us right there, it says 1/2 times 2, right? To the whatever power. So the next number is going to be 2, A sub 2, right? But we could plug it in, or we can just realize that since n is 2, let me show you. Since n is 2 now, minus 1, that becomes a 1. So it's 2 to the first power, so that's just 2, right? So 1/2 times 2, so A sub 2, 1/2 times 2, those cancel out, is 1. So we notice if we do 2 times 1/2, that equals 1, right? We're just multiplying by 2 to get the next number every time. We can see that. It kind of tells us right here, we're multiplying by 2. The exponent just allows us to go the next number over every time. So if we just keep multiplying by 2, we can get our first 4 terms. right there. And then it says what is the 8th term, or a sub 8. You substitute in an 8. So that's just saying what would the 8th term be. So, or you can just keep multiplying by 2 till you get to 8. So 8 times 2, that's 16. That's the 6th term. 32 is the 7th term. 64 would be the 8th term. So let me go ahead and squeeze out some more. So A8 equals 64. Maybe this guy needs to stay. Number 9, pretty much the same concept. You just substitute it in. So 1, 2, 3, 4, and 5, you substitute in for those numbers. So 7 plus 2 times the 1, I'll just write it once. 1, substitute in. So that's just 7 plus 2, right? 7 plus 2 is 9. And basically we're just adding 2 every time, because 2 times 2 is 4 plus 7. That's 11. Also, 9 plus 2 is 11. We just keep adding, substituting, however you want to do it, and we can get our first 5 terms. And then we do a sub 13. I'll do that right here. So 2 and n is 13. So basically 2 times 13, that's 26. 26 plus 7, that is 33. So these are quite easy. We just have to substitute them in. Now we have number 10. Write an equation that could be used. So first we're going to see what's happening here. So there's 2 boxes here, 4 boxes here, 6 boxes here. So basically in between each one is plus 2. So we always start with our initial value. So 2 is our initial value. And then we have plus 2, right? But we need to know, we want to know every single possible answer, not just these 3. So we're going to put the n minus 1 from our arithmetic formula. Okay. The reason why we have the minus 1 is because if our n was 1, so we substitute it in here. I'll just do it over here. If our n's 1, it has to equal our first term, which is 2, right? So 2 times 1 minus 1. The only way it would equal 2 is if we had minus 1, because 1 minus 1 is 0. 2 times 0 is 0, and all we have left is 2. If we didn't have the minus 1 there, it would just be 2 times 1, which is 2. 2 plus 2 is 4. So that's why we have the minus 1, to make sure we get our original value. Now we're just going to do the 10th term. So instead of n, we're going to put 10. 10 minus 1 is 9. 9 times 2 is 18. 18 plus 2 is 20. So hopefully this was able to help you out a little bit. Got a little bit of understanding of the review, and good luck on your test.